Good day, ladies and gentlemen. Thank you very much. It's Mr. Nambane again. We are currently busy with our series of videos for vertical projectile motion. We did a couple of few where we explained how best you can tackle the problems given to you. So now we need to move towards more complex questions. So in this instance, today we'll be looking at how to approach in a situation where you are given now two objects. So if you are given two objects, how should I be able to treat that? One of the hints when working with that should be at A, now you need to draw the sketch. So drawing a sketch will basically assist us in terms of knowing what information is given and if there are any differences thereof. But now, secondly, we should be able to identify the variables that are given. So identify variables that are given. So with variables that are given, it will assist in terms of doing a calculation for a specific information. So this one will now be object specific. So hence it will be best if we do now explain exactly which object are we working with. So hence I say it will be now object specific. So it will be information for object A and information for object B. But we need now also to have a relationship between the two. So what do we need? We need now to check for a common factor. Check a common factor. So common factor in this case can be maybe your time, can be your distance thereof. So depending on information that is given, it will allow us to write the correct information as it unfolds. So this being the examples that we or hints that we need to look into. It says once I am given this information, the easiest thing to do will be to draw a sketch and then identify the variables, but now the variables should be object specific. Then look for a common factor, and then that common factor can either be time or the distance that is now given. So I'm going to try and explain this with a question paper or a problem that was asked a couple of years ago. So without wasting time, let's go into it and check the information that is now given to us. It says here a man throws a ball A downwards with a speed of 2 meters per second from the edge of the window that is now 45 meters above a dam of water. So firstly, let's draw now a sketch for ball A. So what is happening for ball A is we have this window, and then the man is going to drop now ball A with a velocity of 2 meters per second. At the very same time, we have now the water that is now somehow 45 meters above. So that is the first information we have. Then the second information from the question says now 1 second later he throws a second ball B downwards also, and observes that both strike the surface of the water in the dam at the same time, and then ignore now the air friction. So by that statement only, we are able to know that this we can apply our equations of motion or we can apply our formulas as per formula sheet, and we know for sure that now we are working with a projectile motion. But there's some information also that I need. Maybe I should write this one in blue, that ball B now, from the same height, it was also dropped now, but this is for B. It was also dropped, but it was dropped now 1 second later. So this is the information that is given to us. So what do we need to do? We need now to identify the variables. That is what we did. What is common between the two? It's time, because now we have been informed that it was now dropped 1 second later after A has been now thrown downwards. So we are going to try and use this information such that we are able to get now to the correct answers. We usually opt for the easiest way such that we are able to understand the physics principles easier. So we are working with a projectile, then I need also to have a choice of direction. So everything in this case it's moving downwards, so the easiest thing to do is just to choose my downward as positive. Then let's look at 5.1. So at 5.1, which object are we working with? It says here now, calculate the speed at which ball A hits the surface of the water. So like I said, now we identify our variables for A. It is always advisable for you to inform the marker or inform the person who's going to read your answer to specify which object are you working with. So if now the question is based on A, it's easy for me to say, let me focus on everything that went through or that A has in terms of the variables. So I am told that the V initial here should be now 2 meters per second. I also now know that my delta Y, in this case, it's now 45 meters. Do I have time? No, I don't have time. That is what I don't have time. Do I have G? Yes, G is always given, which is 9.8 meters per second squared. The question wants now what? The speed at which ball A hits the surface of the water. So I am now going to look for V final. So it says to me I should be able to analyze in detail such that I can be able to write now the correct data or the correct information for ball A. So when I check now my formula sheet, I find that now the appropriate equation here is Vf squared is equals to Vi squared plus 2G delta Y. Then I am looking for V final. I am told that this is now 2 squared plus now 2 multiplied by 9.8 multiplied by 45. Now remember that now everything is downwards, so hence my G will be positive as well, and then my 45 will be positive, and then my V initial will also be positive. Then when I go further, I find that everything here will be something like 886. Let me correct my pen here. I'm going to have 886, and then I'm going to take now the square root, V final 8, then my V final will be something like 29,77 meters per second. Obviously they just wanted the speed, so there's no need for us to assign direction to that, but we know that it should be downward. So that is now for 5.11. And then they say now to us, calculate the time taken by ball B to hit now the surface of the water. So at 5.12, the challenge is there isn't any much information that I know about ball B. So if that is the case, can I relate the information of A with B? Yes, I can. Remember, we did say that now we have a common information between A and B. In this case, it's now what? It's now the time between the two. So if I'm able to calculate the time taken by ball A to reach the surface of the water, I can easily now subtract 1 into that time. Then I will be able to get the time taken by B. So it says still I will also be looking for calculating the information for A. So for A, still I am going to use the same data as above, but in this case I'm just going to calculate now for time. So I'm going to use VF is equals to V initial plus now GT. Then I know that I have my final velocity as 29.77, which is equals to V initial was given as 2 meters per second plus now 9.8 T. Then solving for T, I will find that my T is something like 2.83 seconds. But now at this time here, I must specify that this is for A. Hence, it is always important to emphasize as to what are you calculating. So I just calculated for A. So the time taken by A to hit the ground. So it means now for me to get the time for B, I should be able to say TB is equals to now TA minus 1. Remember, it was now thrown downwards 1 second later. So I know that now this is 2.83 minus 1. It will give me something like 1.83 seconds. So this is now my final answer. And I have used now the common information or the common factor between A and B. But if I was not able to understand this information that is given here, as it was now thrown 1 second later, it will give me now a challenge or a problem for that matter. So when you check this information, it basically says we are now able to use the information of A for us to get the information of B. So always look for a common factor or a common variable between the information that is given. So I'm going to move now to the initial velocity of B. So calculating the initial velocity of B, I'm just going to clear this because I'm going to need the space for that. Then I will be able to calculate. I will be able to calculate for V of initial velocity for ball B. So let's go back into it and check what other information do we have. So we are going to calculate for B. So when we calculate for B, what is it that we know? We know that at 5.13 we have delta y now, which is 45 meters. We also have the time we just calculated, which is 1,83 seconds. Do we have V initial? No, that is the question. Do we have G? Yes, we have G, which is 9.8 meters per second squared. So we did say you always need only 3 variables in order for you to perform a specific calculation. So when you check the information that is given, we have everything thereof. We don't have V initial, we don't have V final. The only thing we have is now the time taken to hit the ground. So when I go to my formula sheet, it will be easy for me to say, can I use delta Y, which is equals to VIT plus half GT squared, VIT. Then I know that everything in this case must also be positive because delta Y is to the downwards, G also to the downwards, and my time will always be positive. So I will have my 45 here, which is equals to my V initial is what I am looking for, into now 1,83 into 1,83 seconds plus half now of 9.8, and then my time is 1.83 squared. Then when I do the mathematics, I find that I'm going to have something like 45 minus 16,49, which is equals to VI into 1,83 seconds. Then I solve for that. I eventually get my V initial as 15,6164 meters per second. Meters per second. So let me just correct my SI unit, meters per second. Meters per second. Then this is now my final initial velocity, but I need to specify also that now this is for P. So I am expected now to draw a velocity versus time. So they say here, sketch a velocity versus time graph for the motions of the ball A and B, and clearly indicate now the following on your graph: the initial velocity of both A and B, time release of B, and then time taken for both to hit the surface. So let's go at 5.2. Because now they were moving in the same direction, it's easy for me to say, let me have my axis, because I didn't have any change in direction. But what do I know about A? I know that A was released at 2 meters. And then I know something about time, that it was released, B was released 1 second later. And then for me to complete the motion for the 2 balls to hit the surface of the water, it took something like 2,83 seconds. Remember, you must label your axis. This is now time in seconds, and now this is velocity in meters per second. So let's start with A. It took this much, and then it did complete at 2,83 seconds. So now I must label, now this is for ball A, but I know that ball B was released now 1 second later. So it means now for B, is going to start at 1 instead of 0 seconds. But what else do I know? It also took 2.8 seconds or 83 seconds for it now to hit the surface of the water. So now this is for ball B. But what was the initial velocity thereof? It was 15.64. 15.64. So this will be now my graph for the situation when I am given two objects that are experiencing a free fall. So in this case, it's just an issue like we explained in the very first diagram to say, draw a sketch, identify the variables, and remember the variables will be now object specific. Thereafter, you check now for a common factor. It's either a distance or time between the two. Once you do that, it makes it easy for you to build into this information. It makes it easy for you to have the structure that you can work with. So from me to you, I thank you very much, and I hope this lesson will give you all the hints when you are working with two ball situation or two objects that are given to you. So don't forget, tell a friend such that you can be able to assist one another with physical science. Like and subscribe on our channel, which is Nambane Academy on YouTube, and then we also go by the name Nambane Academy on Facebook and YouTube. So kindly follow us and share the links, tell a friend about us, because all we are trying to do is to ensure that everybody is doing well in physical science. Thank you very much and have a lovely day.